So my name is Graham Lawler, and I'm the founder of Ultralight Startups. Ultralight Startups specializes in helping corporations connect with startups. We host pitch events and online communities. We've been around for about 5 years, and we've held over 120 of the pitch events that you're going to see here tonight. We do a series for high-tech startups, and we also do a series for energy and clean tech startups. And that series is called Future Energy, and that's what you're here to see tonight. Future Energy is sponsored by Shell's Game Changer Group, and we are which you'll be hearing from in a moment. Ultralight Startups is the largest pitch event community in New York City, Boston, and Silicon Valley. You'll be hearing a little bit more about our events upcoming in New York, Boston, and Silicon Valley in a moment as well. Here's my co-host and co-founder, Chris DeLuca, who's going to tell you about the format of the event.
Thank you, Graham. So welcome. As Graham mentioned, my name is Chris DeLuca, and I run the Ultralight Startups and Future Energy communities in Boston. Here's the format for tonight. So in just a moment, we'll introduce you to our brilliant energy investor panel here on stage. We'll have 8 startup pitches, and then we'll move into a contest. This is a voting contest which you'll be able to participate in, as Graham mentioned. So hopefully you picked up a program and you're following the companies and the presentations along and taking notes so that you can vote on your favorite companies as well as your favorite panelist. We'll conclude in the Potomac Foyer, which hopefully you can join us for coffee, refreshments, and networking. Graham, tell us about how we selected the 8 companies tonight.
Okay, so there were over 200 companies, energy and clean tech startups, that applied to present here. You're going to see 8 companies. So we filtered those down in a number of different ways. First, we're only interested in early stage companies. So basically anybody before a Series A round of venture capital. Early stage companies is what we're interested in. We took the early stage companies and we posted them on a crowd voting portal that you may have seen and participated in, and offered anybody on the internet the ability to view profiles of these companies and vote on which ones they wanted to see here. The top 2 companies that got the most votes in the crowd voting contest got automatic bids to pitch here, and you can see those identified in your program. The remaining 6 were selected by our selection committee. And we tried to find a cross-section of technology, so something for everyone, in a variety of different subsectors within clean energy and clean tech. We also have 2 ARPA-E awardees amongst that list, so those are identified in your program as well. And finally, all 8 companies did receive coaching, although they're early stage, and this may be the first time that some of them have pitched in public. They all were coached. So next we're going to talk about our panel and introduce our panel. So in alphabetic order, from David Miller, we're going to go down the line and we're going to have each of you talk about your firm and the most recent clean tech investment that you've made and why you're so excited about it. So David Miller from Clean Tech Venture Group, let's talk about your firm.
So our group is called the Clean Energy Venture Group, and we're actually not a venture firm, we are an angel group. So we are composed of folks who are operating executives, experienced running companies ourselves, who are now trying to give back and making individual investments in very early stage clean energy companies. As an angel group, we don't have a ton of capital, but with 14 partners, we have a ton of experience and relationships, and we try to leverage that experience and relationships to help our companies succeed. The most recent investment that we've made is in a company called Practically Green, which is an online sustainability platform. And so it's a platform that enables individuals, and they're focusing very much on employee engagement for corporations, so employees of corporations, to be able to track their sustainability. So that you can look at specific actions that you can take that lead you to a more sustainable lifestyle or a more sustainable work style. And you can track each of those actions and track the impact that you're having over time. And a corporation can track the impact that its entire workforce is having over time. It's a very powerful platform. It's very engaging. I encourage you to check it out, practicallygreen.com. We're very excited about the prospects of this company because it really enables a large-scale adoption of sustainability practices.
Fantastic. Thanks so much, David. Richard Smith from Shell's Game Changer Group. Tell us about Game Changer and your most recent investment.
Certainly. Shell Game Changer is a global team. We have people all around the world, and we're, again, more of an angel investor, but we're interested in the revolutionary rather than evolutionary technologies and business models, anything connected to the energy industry. One of our most recent clean tech investments that I'm excited about is a company that is creating electricity from kites, wind power. It's exciting because it's a little bit crazy, and we're very much looking forward to seeing it come to fruition.
Fantastic. Thanks so much, Richard. Yaniv Suissa from New Enterprise Associates, NEA. Tell us about your firm and your most recent clean tech investment.
Sure. So NEA is the largest VC in the world. We have $13.5 billion under management and a $2.6 billion fund. We invest in tech, clean tech, and healthcare. And in clean tech, we have a little over, I think it's about 35 companies now and over $1 billion invested in the space. We're in Silicon Valley and DC. As well as China, India, with satellite offices in New York and Chicago. But we invest everywhere, and we invest at all stages. So we'll do a $100,000 seed stage check up to the $50 million growth check, but we're actually primarily early stage investors, so we usually do A, B, that kind of area. But there's someone at NEA who does everything. Most recent company that comes to mind is probably a company called Cubotics out in California. What Cubotics does, so solar's been a really tough market, as a lot of you know. And Cubotics helps with the balance of systems for solar. So they have a robot tracking system that moves solar panels with the sun and takes out a significant amount of cost from any solar installation, and they're doing very well.
Why were you so excited about that particular investment over anybody else that has pitched to you before?
I don't particularly know. Well, it's something that's really necessary. I think solar is going to grow, right? And it's difficult sometimes to invest in generation right now, but in terms of actually installation of solar, it's still happening and growing internationally, and anything that reduces balance of systems really helps you out, since it's harder and harder to increase efficiency and try to increase efficiency in terms of generation.
Okay. Thanks, Yaniv. So David Wells from Kleiner Perkins, Caulfield & Byers. Tell us about your firm and your most recent investment.
First, thanks for having me. Kleiner Perkins is a Sand Hill Road-based venture capital firm with offices in Shanghai and Beijing. We have about $7 billion under management, and we celebrated our 40th anniversary last summer. And in the history of the firm, we've made about 700 investments, most of them in early stage innovations across life sciences and digital and green tech. We have 5 practices in addition to those I just named that invest from our venture funds. We also have a green growth fund and a digital growth fund for later stage opportunities in both of those areas. I'm a partner in the green venture practice, and we invest in innovations in energy and resources, generally early stage investments. Can't talk about my most recent investment, it's in stealth stage, but I'll speak about one we made recently from our practice. It's a company called VoloAgri, and it's the business model is to roll up small seed breeders who have innovations in fruit and vegetable seeds and connect them to our global distribution and marketing platform in the company. And we find this to be a really exciting investment because these seed breeders are very skilled, and their abilities are producing food that leverages resources, topsoil, water, arable land, but there is no good infrastructure to get these innovations to market. And we think we're going to be able to make an impact on food availability and pricing globally with this venture.
Fantastic. Thanks so much, David. So Chris, would you like to tell us about the format of the pitch?
Sure, thanks, Graham. So here's the format of the pitch. It will take up 9 minutes total. It's broken down into 3 segments. We'll have 3 minutes of monologue pitch right around here from the presenter tonight. That will move straight into 3 minutes of question and answer. The questions will come from the panel to the presenter, giving the presenter an opportunity to respond to those questions. That will be interactive. And then the final stage is 3 minutes of feedback coming from the panel, which the presenter has no chance to respond to. So this is takeaway advice. It's in the format of, we're asking the panel to basically put themselves in the presenter's shoes, think about what they would do if they were in that position to go on and grow the company to the next stage. That's the format for tonight.
And whichever presenter you feel gives the best actionable advice and the best feedback should get your vote.
That's right. And speaking of voting, as mentioned, this is a contest. So the presenters will be voting for not only your favorite pick, but there'll also be a competition amongst the panel. So it's going to get heated up here. So they're going to be very competitive, competing for your votes. And we just want to say thanks to the contest partners. We've got Clean Tech Open Northeast, Green Start, Agrion, and Surge Accelerator. So thanks to all the contest partners for supporting this competition tonight. Graham, let's kick off the pitches.
Okay, so the first pitch is Stuart from BDL Water. Come on up, right around here somewhere.
There's echo. Makes it really hard to hear. I can't understand what they're saying.
Yeah, is there an echo? A bit of an echo. Yeah, come a little closer maybe. And 3 minutes whenever you're ready. Go ahead, speak into the microphone.
I know. Okay. There's a crisis going on in the world right now on frack water. It's not a problem anymore, it's a crisis. And the reason it's a crisis is because last year over 1 trillion gallons of water were used to fracture oil and gas plays in shale. We get a lot of energy back, but that water comes back too. And at the moment, the industry does not seem to have a logical or a workable solution on what to do with these ever-growing amounts. We figured it out. We are about to launch a revolutionary and paradigm shift technology that will solve this problem once and for all for the industry. My name is Stuart Forrest. I am President and CEO of BDL Water, and we are a recycling treatment company with a game changer. Part of what we've done here is the fact that makes us unique is that we can treat 100% of the water. Not 50%, not 60% or 80%, 100%. We have no reject water. There is nothing that needs to be transported to a reinjection well to be disposed of. And we can do all of this at prices that the industry is striving to have. Pardon me. Essentially what you have is a barrel in, is a barrel out in terms of its treatment ability to do that. And we've accomplished all of this through some modular technology that allows us to treat 5 times the TDS levels of any current technology that's out there. What we're looking for right now is a situation to play off of our tests that we did out west with real producers like Anadarko and Canna Peak, where we treated their real water to unbelievable levels that were successful. They're waiting for us to come back. What they're really excited about is the fact that our technology will be proximal to their operations, thus eliminating long-distance travel, also being able to do the turnaround and give them back the water that they need within the field. We're seeking $10 million to launch our first new facility that will treat 1,200 to 1,500 barrels per day. And with these will be followed by sites that will treat a minimum of 25,000 barrels a day. With the way regulations are changing and going on right now, we're sitting, as we would say, in the catbird seat because we've already solved the regulation problems that are out there right now. And we know going forward with the demands that the energy sector is going to have for this kind of clean water that we can deliver what the industry looks for. We're predicting that within 3 years, we will have a revenue stream exceeding $250 million annually.
And time. Well done. So we'll hold the applause till the end of the session. We're going to move right into the QA session right now. I just wanted to give you a sample. 3 minutes is not a lot of time to give technical depth on a pitch. So well done. We just want to give you a taste and variety of all the companies to give you a nice show tonight. But hopefully the short format will help give you a breadth of different companies. So well done. We'll move right into the question and answer. So Any order? Anyone can jump in.
David's got a question. Go ahead.
Looks
Dave.
like Dave has a question.
Sure. I have a few questions, so I'll throw them out there.
Okay.
First of all, how high in parts per million TDS can you treat? How much energy does it consume to...
Some kickback coming back from that right now. Go ahead.
Yeah. How much energy does it consume per unit of water to do that treatment? And then what's the capital expense of your system and the ongoing operating expense to run your system?
The energy requirements that we've got right now are less than 27 cents a barrel.
Okay. And how high in parts per million TDS can you handle?
What's really unique here is that we have technology that can handle up to 375,000 TDS.
And what's the capital expense of your equipment and the
We're
ongoing operating
looking for initially here the 7 to 10 million, actually 10, because what we want to do is deploy a real working depot, not something that's a demo unit, but one that has inbound producers who are bringing that in, so we eliminate that problem, but we also generate a cash flow. We don't want to be out there just testing water and don't have a cash flow back for investors.
Yaniv?
Sure. The oil and gas industry is pretty difficult to break into in terms of sales, right? Just like utilities. I'm sure half the audience is annoyed about that. What is your plan for selling this and getting further along down the road? Because at some point you need to de-risk the capital, right? The raising of things.
The plan is simply that when we set up the depot, the inbound water that will be treated will be from producers that we have already gone to. In other words, we're seeking, this is a design, build, own, operate model. It's a throughput contract. So what we're saying is we'll take care of your water for 3 to 5 years at a fixed rate per barrel. You just bring it here and drop it off. Or build us a pipe and bring it here. And then an expansion where the technology is modular. So from a facility that would be built to expand it from 12 to 1,500 barrels a day to say 7,500 does not require a change in the footprint. We can do that inside based on the way it's configured. So we can increase the amount of treatment without expanding the facility.
Richard?
Yeah, what do you do with the waste chemicals once you've separated from the water?
Basically, we're bringing that water in. We will treat it so that it becomes water that will be of either irrigation or agricultural quality. We could make it potable if you wanted it, but there's not a need for it in the industry to do that. But we want to be able to make it so that it is available for the industry to be used as clean water for fracking, because that's a heck of a problem for them right now.
And the other streams, so all the stuff you've taken
On the
out.
backside, obviously, you've got a concentrated brine stream, which is the bugaboo, which is what everybody's re-injecting. We have found ways to take that and convert it into other products that are sellable to other industries or back into the oil and gas industry.
And David. Who else?
How many people are in your company today?
6.
And in how many different geographies or basins have you treated produced water?
Basically, we have treated things from the western United States, which would include Colorado, Wyoming, Texas, and Louisiana.
And do you have a core innovation? And if so, how is it defensible against fast followers? Or is this a topology arrangement?
Well, obviously, if I were to tell everybody exactly what we've done here with the mousetrap, I'd be shooting myself in the foot. So there is a lot of technology that's here that allows us to be able to treat 5 times the TDS level and make that work at a cost for treatment that makes it work for us. Okay, there's no sense having a solution for which there is no problem. So we're not going down that road either. But the ability to do a design, build, own, operate allows us to control the technology, which is why we're not selling it anywhere, because we would really like to be a game changer in the industry, and the only way you can do that is control your operation.
Great. So that concludes the question and answer segment. Let's move right into feedback. So, David Miller, you're in Stuart's shoes. What would you do the first thing when you wake up tomorrow morning?
Sure. Well, we have a saying in our group, if they can do what they say they can do. So if you can treat 375,000 part per million TDS water at 27 cents of energy operating cost, and that's almost all of the operating cost, that's extraordinary. It's not clear as what proof of concept you've developed. It says commercial prototype. So if you actually have a working system that's operating, demonstrable, to get that out to your potential market, to potential customers, get systems out there in operation as soon as possible if you haven't already, at customer sites, to prove the durability of this over time and the performance over time in an actual customer environment. And if you can do that, and if you're at a price point that's going to work for them, then I think this has tremendous potential.
Feedback, Richard?
Yeah, and I think David's got a good point. It's barriers to entry are high, and if you can get hours of customer service down, that would be good. So you may want to look at, I know I didn't get the chance to ask you, but fracking itself, there's a lot of other problems with water out there as well in the industry. Produced water, water offshore. If this thing's as good as it sounds, I'm sure you could deal with some of those as well. So there may be other niche markets out there that may be better markets to start in. But
from a VC investing perspective, it's going to require a lot of capital, this company, over time. And so that's usually a problem for VCs in a lot of ways and for financing, right? And there's two ways to counter that, right? And I didn't hear a lot of strategy around this when I asked the question. One is to create partnerships for research or development or for pilots or whatnot with some of the big guys who you might be selling to at the end of the day. Right, didn't hear that. And the other, I'm sure there's more than two, but the other is to have a real strategy for how you're going to guarantee a revenue stream, right? You're dealing with big players, it's a consolidated industry, and they're tough to break into. So I think having a strategy around that would be really great, because you can build a great technology, but you need to be able to sell it effectively and raise money to be able to grow your company.
And feedback, David.
So I would echo Yaniv a bit that a build, own, operate model for a startup uses the most expensive capital in the world, the capital that a startup raises. I would try and leverage partners to finance especially your early plants, and maybe all of them, because their cost of capital is much lower. And then two pieces of advice around pitching the company and positioning it. One is to go from a startup with some field trials to 250 million of revenue from 6 people today. It's not really very credible. We all see these business plans that have got these huge hockey sticks in them, and in this field, it doesn't work out that way. Those kinds of things happen in internet businesses with network effects. And in this business where you have to raise very expensive capital in order to create your revenue, that kind of hockey stick isn't very credible, and a lot of investors are going to dismiss it. So I would make a more modest plan that was more credible and that was more granular about building the team and building the business. And I would also try to raise less than $10 million in this round. That's a big ask from where you are to getting a $10 million check. I would look for a lower, nearer target.
That's very actionable advice. Thanks, David. Raise less capital and more modest projections. And thank you so much, Stuart.
Thank you very much, gentlemen.
Okay, round of applause for Stuart.
I've seen this company. It's just like, oh my God, another big hockey stick.
So next up we have Jeremy McCool with Hevo Power. Yep, there's no switch.
You can? Great.
Go ahead.
Hello, my name is Jeremy McCool, and I am the founder and chairman of Hevo Power. Hevo is a service-disabled, veteran-owned small business that is headquartered in New York City. Our company is developing a wireless charging network for electric vehicles with a team of engineers at NYU Poly to meet the needs of commercial fleets who have either began to transition.
Could you speak like sideways so that they can see, but we can hear you?
Does this take off my time?
Just sideways.
Okay.
Yeah.
So
No
you
problem.
won't be able to hear me. Anyways, we are developing a wireless power charging network for electric vehicles with a team of engineers from NYU Poly to meet the needs of commercial fleets that have either begun to transition to electric vehicles or are looking for a viable option, EV option, that actually works. These fleets are feeling the pain at both the pump and at the plug. Moreover, fleet operators with EVs are constantly plagued with pains like battery range, driver error like forgetting to plug in the EV, or things like a constant check-and-see charging regimen. We believe our wireless charging network has the cure for the cord. Currently, the typical urban-based commercial EV takes anywhere from 8 to 12 hours to charge. Our station, which can be either surface-mounted or embedded like a manhole cover, will take up to 2 times faster in terms of charging than the typical plug-in unit, and anywhere from 3 times faster than the typical wireless charging unit. Excuse me. Our station, the Hevo Power Station, will also be able to work with any EV outfitted with a wireless receiver. The Hevo mobile app will provide users with the control to be able to locate their charging info on their phone and also be able to remotely drive themselves into a parking station. Now, our Generation 1 product launch, and I'm not getting too close to that for feedback, by the way. That's perfect. Is in 2014. And our first customers are urban-based commercial fleets that are coming on the line with EVs. The market, as you see it today, shows the market being at 18,000 vehicles in 2015 and increasing to over 80,000 vehicles by 2018. By capturing 15% of this $300 million commercial EV charging market with just the wholesale of our units alone, Hevo will drive $45 million in revenues over the next 4 years with a gross margin of 50%, that's 50. The Hevo Power Station will wholesale for $2,500 and the vehicle receiver will wholesale for under $1,000. The Hevo mobile app will be introduced to users free of charge. Hevo Mobile, or I should say Hevo Power, has unlimited potential and scalability. Our products can provide wireless charge to municipal and military fleets and the up-and-coming passenger EV market. From commercial loading bays to a public charging network to wireless highways. Imagine a world without cords. Hevo Power will redefine the way that people drive and how they live, and it will only cost $4 million.
And time. Thank you. Okay, so we're going to move right into the question and answer section. So
Thank you.
In any order, who'd like to jump in? Who has a question? Yes, Richard.
So I'm in my car, or I'm in my vehicle, and I drive over this manhole cover, and I have a similar manhole cover thing on the bottom of my vehicle.
I'm sorry, I'm having...
So a manhole cover in the ground, manhole cover on my vehicle,
yes.
And there's a wireless transfer.
Yes.
How much of the electricity is transferred?
How much electricity?
Oh, how much of the power? I mean, what percentage is wasted?
We are developing a charger that can charge up to 10 kW right now. We have tested for units that are already charging in terms of kilovolts. So that's 6 times more than what's even on the market.
So what, I mean, how much is lost in the process?
How much efficiency is lost?
As a percentage.
What really matters, and you're asking for efficiencies. So at the gap that in terms of the distance for an electric vehicle, which is about 9 inches for a typical urban-based commercial EV, we will be able to charge in a 90th percentile plus.
Right. And what happens to the other 2%?
It's lost through
does it go into heating up my car?
I'm sorry?
Does it go into heating up my vehicle, or what does it go?
I cannot understand what you're saying. I'm sorry, Richard.
Okay. Where does that 2% go?
Where does the other 10% go?
Does
it dissipates into the electromagnetic field that already exists.
Okay.
It doesn't go into, just to let you know, our units are non-radiative, and they have an RFI which is 100 times less than a typical cell phone. By the way, the magnetism is 1,000,000 times less than a typical MRI. And just to prove the point how safe these are, we're having NYU Medical conduct a series of independent tests over the next year just to continue to prove that point.
Okay, thanks.
Question, David. Yes.
Yes.
What is the cost of installation of the stations in the ground?
It depends on where they're being installed. So in a loading bay, in a commercial loading bay, that installation is going to cost anywhere from $1,250 to $1,750, depending on what they want to do for the hookup. And we have installation partners that will be providing that. So the way that we have already conducted ourselves in terms of distribution, we have a exclusive distribution license with the largest EV agent and leasing agents, I should say, on the Eastern Shoreboard with a company named Malaya. Yeah.
Why are you projecting 3 times the charge rate?
So that's 3 times more than our wireless charging competitors. So the reason why that is because they're right now building most of them are building a unit that can only charge up to 3.3 kilowatts. They're focusing on passenger EV fleets to be able to put these in home garages, basically. We are not focused on that.
Are there moving parts in your receiver?
There's no moving parts. It is embedded into the chassis so that it doesn't even hang down.
From a business model perspective, right?
Yes.
Why would I, fleet owner, decide to go this route where I have to build out stations and retrofit vehicles versus a clean fuels-based vehicle versus a hybrid? So how do you compare those 3 in a apples-to-apples way, and how do you guys stack up against those other 2?
So you're asking basically on the difference in the fleets, right? So if you're going to be an urban-based fleet versus a highway transport fleet. Is that what you're asking?
As a fleet owner, I could either buy vehicles that run on clean fuel,
right.
I could buy your vehicles, I could buy hybrid vehicles. Why would I pick your vehicles versus the others?
Well,
from a business model perspective.
From the business model. Okay, so first thing, we don't have anything to do with the vehicles. Those are being developed and produced by Smith Electric and other companies like that. Navistar, E-Stars, guys like that. We are capable of being able to charge any of those vehicles with our HEVO power station, and we are developing the receiver that can work with that. Now, the difference is that these urban fleets have already began to transition into these electric vehicles simply because of the numbers, to be quite honest. These guys are seeing economic increases in their own productivity and dropping prices by anywhere from 12 to 20% by switching over to EVs. The highway side of it is different because obviously an electric vehicle right now simply doesn't work for a highway support.
No more questions. Perfect. So let's move straight into the feedback, and there's no response here. So David Wells, what feedback would you like to send Jeremy on his way with?
So I think that one of the areas where your responses were a little weak was on the parametric competitive analysis. The unit cost business reason why a fleet owner should invest in your product rather than one of the other solutions out there, including one of our own portfolio companies, Proterra, which makes a fast charge electric bus and has a fast charge system. And you really need to have a really good parametric quantitative analysis to drive people's appreciation of what you have. And the other thing I would say to you is partner, partner, partner. This is a chicken and egg business where you need to have the vehicle and the receiver, and you need to have the thing in the road. And the only way you're going to accomplish that, even if you do have great economics, is by forming really strong partnerships. And you should be evaluating who's going to be your first partners, how you're going to partner with them. You should have a whole pipeline of it and treat it like a sales process.
So I've seen you before. I think we've talked, actually. So I actually have a book coming out that will solve. If he gets to market, I get to market. Not really. I think last time I stole David's comments, and this time he stole mine. I think. And this seems to the other pitch suffered from the same problem. It was that you really need to think about, at the end of the day, the business from the perspective of your customer, right? When they're trying to figure out the business case, what is it? And given other alternatives, why is this particular case more attractive? That's that.
Yeah, talk about stealing questions. Yeah, I think for me it was one of the areas I didn't see. You mentioned you had a plan for urban-based commercial vehicles in 2014, and you implied there were customers. I'd like to see in the pitch, if you have those and they're lined up, who they are, where you're going to put this. That would be good information to see.
David.
So also agree very much with the other comments via partnership. So you say you're going to have Gen 1 units in early 2014. It's early 2013 now. And so how are you going to use that year? The markets you're looking to get into, MUSH, commercial fleets, these are long sales cycles. So I would work on, as much as you can, getting into those sales cycles today. If you have prototypes, if you have some working systems, developing those partnerships. Start as soon as you can developing those customer relationships and getting into that sales cycle so that when you're ready to deploy, that you're further along that path.
Awesome. Thank you so much, David. And thank you, Jeremy. Round of applause for Jeremy and Hebo Power. So next up we have Tucker Gilman of Other Lab. So Tucker, you have 3 minutes.
Great. All right, so my name is Tucker. I'm from Other Lab, and I'm going to talk to you guys about conformable natural gas tanks. All right, so currently natural gas tanks are big cylinders. They're cylindrical because that's the shape that physics says is the best shape. And they're big. I say they're big because they need to be 4 times the size of the same tank if it was regular gasoline. So why is this a problem? It's a problem if you're trying to stick one of these tanks in your car. It's just really difficult because your customer, people who buy cars, they don't want to sacrifice range, smaller tanks, and they don't want to sacrifice trunk space. They're fickle. Yeah, sorry guys. The feedback's pretty bad up here. But yeah, so how do we solve this problem? Well, we looked at it and we said, changing the shape of the tank is going to be really difficult because physics says that's hard. What we can do is we can reduce the diameter of the tanks and if we're keeping the volume the same, this makes them really, really long, right? And so then what you can do is you can sort of take these reduced diameter cylinders and fold them up into neat shapes. And what this gives you is really, really high conformability. You can basically approximate any shape you want if you can figure out how to manufacture it. And so other gains you get, besides extremely high conformability, is you get about a 10% jump in volumetric energy density. So you get, because of like boundary condition reasons, you sort of go from 76% to about 91%. That's volumetric storage density. And also you get an inherent safety benefit, because if you have a big tank, say you get a hole in the tank, and that's what everyone's afraid of with natural gas, right? High pressure tanks in your car. Everybody's scared. So if you get a hole in one of those tanks, all the energy comes out at once. With one of these tanks, you have a lot of sort of, the surface area is much greater and a lot of chambers connected by sort of smaller conduits, and then so all the air that leaves, you know, sort of doesn't come out at once. So the energy escape is much, much less. Slide. So this slide is all messed up, but yeah, that's not my fault. So why is this a good idea? Like, why would you buy this at all? We like it at Other Lab because we feel that we're going to know if it's a good idea or not in a very short time period. We think that within a year we can get this into a car and know if it's a good bet or not. With relatively small amount of time and money, we can prototype this thing, and we have partners in the automotive industry. You know, we stick this thing in one of their cars, and we're driving around within the year. So right now, where are we at? We're building a Type 1 and a Type 4 tank. So a steel tank and a composite tank. A steel tank because auto manufacturers can handle steel as an idea, and a Type 4 tank because we really think that's the future. And so whose hands should we get this into? We really think that we want to license or sell this to the people who ultimately are going to take it to the market. OEMs, people that are going to manufacture these tanks and
10 seconds.
Yeah, and give it to the auto manufacturers. So yeah, that's all the time I have for. Thanks.
Well done. So any questions? Any order? Would anyone like to jump in? Yes, Richard.
How much does it cost?
How much does the tank cost?
Yeah.
Well, we'd like to cost as little as possible.
Good answer.
I think less than $1,000. I don't know, $700 would be great. Depends if it's steel or carbon, and its trade-offs in weight. If it's carbon or composite, it's going to be more expensive, but it's going to be lighter. If it's steel, it's going to be cheaper, but it's going to be heavier. So really, you just want to make it cheap and as possible.
So to expand on that, for the same volume of storage compared to tanks that already exist, how will the cost compare?
Cost-wise.
Yeah.
Well, so one of the ideas here is that the tank mass actually stays exactly the same. So, as you basically take the same amount of material and you spread it into a different geometry. So, cost-wise for materials, let's just say it's going to be the same. So it's not a win or a lose there. The real win is just in the geometry. You get to make any shape you want, whereas before you were stuck with a cylinder.
Yes, Yaniv.
I'm interested in those partnerships because I think that's really important in an industry like this. So tell me who you're working with and how you intend to break into the car industry.
Well, no.
Or you can use, so it could be Chrysler, GM, or Ford, I don't care.
Imagine your favorite car manufacturer, those guys, and imagine the guy that they buy the tanks from. Because car manufacturers these days don't really make their stuff. They buy it. And so what we really want to do is talk to the car manufacturers and get them to say, yes, we want this, we'll buy it. And then sit down with the guys who are actually going to make it, because we're not going to make it. We're going to develop this idea, sell it to the guys who are going to make it, sitting down with the car companies, and we're all going to shake hands and be like, they're going to buy it, you're going to make it. Yeah.
So are you selling to the guy who currently makes the tank that you've improved on, or are you selling to the car manufacturer?
It will sort of contingent upon the guys that we're talking to and the people who come up to me during this event and talk to me. But yeah, big players. There's some big players in carbon fiber tanks right now. There's like 3 big players. They're interested. And there's also, smaller companies that have more of the innovation space around composites that are also interested. Want to break into sort of that field.
Question, David.
So you've said that for equivalent storage volume, your tank has the same mass, but it delivers configuration advantage. Have you actually built a tank that proves that?
No, we've only done the models. We're in prototype phase. So right now we've built small pieces of tanks. And sort of we think in the next few months we'll have a full-size 140-liter tank.
And do the small pieces that you've built bear out the mass equivalency model?
Yes. I mean, mostly we've built out the sections that we see as problematic. But yes, I mean, I guess the answer is no and yes. We haven't had enough information to know if we're right, but the problem isn't complex enough, I think, to worry about it in the way that maybe you're posing.
Thank you.
And how will these tanks be built? How will you manufacture these tanks?
So it depends if it's steel or composite, and I think some of the innovation a lot of the innovations is in the composite and trying to figure out how to make these geometries, and it's kind of contingent upon the geometries. Like, imagine that spiral, you would use CNC tube bending if it was steel. You would use braiding if it was composite. It's really, really contingent upon what the car manufacturers want, what types of geometry, and then we would do that.
So we're going to move right into the feedback now, so we can run right down the panel. So let's send Tucker on his way. What should we send him out and do to change the other lab? Start with David.
Okay. All right. Well, I think we're going to see a theme here. Partnerships. It certainly looks, given your market, and, given your material needs, certainly developing partnerships will be extremely helpful on both sides, right? So the fact that you've started that, but to the extent you can develop partnerships to your target market, it's extremely helpful. And getting a better sense of what that target market is, whether you're selling, who along that chain, right, are you actually selling to as a startup? You have to find the right entry point.
Feedback, Richard.
I think there's going to be a few words that come up again and again. Partners, you've touched on. I'm going to let these guys talk to you about customers. I'm going to throw out a new one, which is regulators. My advice would be go and find out who regulates this industry. What you've got to do to keep them happy, and that may be one of your largest barriers to entry. I'd do that first thing tomorrow.
Feedback, Yaniv?
I just blanked, so I'm going to let you go first.
Feedback, David.
I think my concern with your venture is that while it solves one piece of the puzzle for natural gas storage, it doesn't solve the other piece, which is the high pressure. And as long as we need 3,000 psi plus to get enough capacity on a passenger vehicle, I think we're always going to be fueling infrastructure limited for wide deployment. So my advice would be to go and partner with some of the many teams who are developing adsorption technologies to pair with tanks so that we can reduce the required fueling pressures.
And Yaniv.
So I got it now. So my feedback is, all of the partners, even though we didn't name who they were, they all are building electric vehicles, right? So I think you need to go to these customers, really figure out, or to electric vehicles, really figure out why that value prop has been the one that's won over this one so far, and figure out how that is going to change and in what time frame, because that's a capital issue. The other thing that no one talked about that no one knows the answer to, natural gas is a very high-risk bet right now. Given the industry is crazy, everyone has a different opinion, so I'm not going to opine on it. But I would think about how you'd answer investors' questions around that, and how you'd think about the risk in that from an operational perspective going forward.
Okay. Thank you, Yaniv.
Thank you, gentlemen.
And thank you, Tucker. Round of applause for Tucker.
Well done.
Next up, we have Wei Lu of Thin Sheet Zeolite. 3 minutes whenever you're ready.
Hi, good evening, everybody. I'm Wei Liu. I'm going to talk about thin flat sheet zeolite membranes. My research team has recently evaluated and PAL. Before PAL, I worked on product development for Corning Incorporated as a research project manager. So the motivation for us to develop advanced zeolite molecular safe membranes is to address energy efficiency problems for a range of energy-intensive industrial products or processes. In a hot, humid climate, the membrane can be used for air dehumidification and conditioning with more than 50% energy efficiency than the conventional vapor compression cooling technologies. Dehydration of biofuels is another application example. The membrane dehydration can save up 90% energy compared to distillation and adsorption processes. Those pictures show you how our membrane looks like. First, we use tape casting techniques to produce a 50 micrometer thick porous metal sheet as membrane support. Then we coat and glue a 2 micrometer thick zeolite membrane on the surface of the support. The membrane coat is so thin that the membrane sheet behaves like a metal foil. It is strong and flexible. The molecular saving layer provides molecular saving functions. The unique performance attributes of zeolite membranes are the high flux, high selectivity. For the air dehumidification applications, our membrane provides water removal rates about 10 times higher than the polymer membrane. For good zeolite membrane, only water molecules go through, all other molecules essentially are blocked. The thinness of membrane sheet enables us to build compact, light membrane modules that can be easily deployed and installed. For commercial ethanol plants of a 40 million gallon per year capacity, we estimate only 2 membrane modules, as small as a household refrigerator, can be used to replace the large, tall distillation towers. Can we go to the next slide? The next slide, I'll talk about potential economic impacts of this technology. With the fundamental inventions we have made, I think a new business can be built to make and sell high-value membrane products, including membrane sheet and membrane modules. Those products made of cheap raw materials will be unique in the market.
And that's time.
Okay, competitive.
Thank you. That's time. That's all the time for your pitch. So now we're going to move right into the question and answer session. So in any order, what would we like to jump into in terms of questions? What would we like to ask Wei Lu?
So one question is, can this membrane be used in the other direction from what you talk about for actually cleaning water, desalinization, or removing dissolved solids from water?
In principle, yes. I think it should be more energy efficient and also capital efficient for gas phase separation. That's why I talk about air dehumidification, also the vapor phase dehydration of biofuels. This will be, in fundamental, yes, it can be used for liquid phase. Yeah.
Yes, Yaniv.
Yeah, is the real kind of secret sauce of your company the membrane or the process by which you make the membrane?
Okay, we made inventions. We made inventions to make this kind of membrane first in the world. So core invention will be the membrane product structures, also the process of how to make those membranes.
Okay, so given that the first part is the product structure and it costs a lot of capital to build a manufacturing plant, right?
Yeah.
Why have you chosen to go that route versus a licensing? And I'm not sure that licensing is the right answer, but what was your analysis instead of going licensing, going toward building your own manufacturing company?
So what I propose to pursue the market opportunity with the increased degree of technical complexity and production scale. First, we can do the part of the production small membrane size to sell them into the laboratory and the scientific equipment markets. At the same time, we can build prototypes for air membrane dehumidifiers, do long-term performance tests for building applications. Then we increase the size of membrane products to address large-scale industry separation applications. So that's why I propose gradual approach.
Two more questions. Yes, David or Richard?
How much of the stuff have you manufactured? What's the largest area of this product you've built?
For first round initial, I think we just need $10 million to start the pilot production. But if you demonstrate long-term performance of products, then we need about $100 million really to build the new membrane production.
Okay. But today in the lab or wherever you've been making this stuff, what's the largest size you've made?
Okay, membrane sheet size we make in lab about 5 inch times 5 inch.
Okay.
Okay. So we're going to jump actually right into feedback. So sorry, David, if you could move right into feedback. So would you like to give Wei Lu a piece of takeaway advice at this point?
I think from the venture capital perspective, platform technologies are very challenging. I think many of us have lost money investing in platforms. So I think the key thing for you as you pitch this opportunity to investors is to pick a killer application for your innovation, analyze your advantages in that application really, really, really well so that you can quantify them perfectly and make a really good case, and then use some of the things you already explained about a progression of how you reach that killer app. And I think that will make it a more compelling investment opportunity.
Yes. David can no longer go before me ever again. But I actually disagree with the platform technology question. I've not lost a ton of money in platform technologies, and I've been around as long as you. But we do like platform technologies, I think. But the approach that works with platform technologies when you're growing a small company is to pick the application that, one, probably you want to pick the biggest market, and two, the one where your technology has the biggest advantage from a business model perspective, right? And target that, focus on that first. And if that doesn't work and we're running out of money and the company looks like it's gonna die, we can shift. But focus on that first, because that's where you're going to get the most revenue generation and the most traction to be able to grow into the other sectors down the road when you're more mature.
Yes, Richard.
Yeah, I heard that you've got a plan for scaling up the business, and I think that's good, and you've shown that. What I missed, or what was lacking from the presentation, was how you're going to scale up the manufacturing process itself. I don't know, you've said you know how to do it, but I'd be very interested to hear what that is.
And David, feedback.
So you have 3 target customers, and I'm just diving further into the prior comments, which I completely agree with. So you have 3 target customers listed here: laboratory and scientific equipment, OEM of HVAC, ethanol and biofuel producers. Those are they have very different needs, very different scales and markets. So, as said before, I think you want to find the area where's the most market pull, where's the greatest pain, the greatest need. As a startup, it's very hard to enter. So find where that pain is and really focus there first in order, to follow the advice that we've heard several times already is to find that initial market.
Okay. Focus on a market. Sounds like a theme from the feedback. Thank you very much, Wei Lu.
Wait, hold on. Taking a break now.
Okay, so before we go on with the next 4 pitches, the final 4 pitches and the contest, we are going to have a word from our platinum sponsor. So Richard Smith is here with Game Changer to tell us about Game Changer.
Certainly. Thanks, Graham. Without trying to repeat what I said in the intro, Game Changer's a global team. We're angel investors. We like the crazy, wacky stuff, as long as it does obey the laws of thermodynamics, which some of the suggestions we get don't. That's a good start. We're not afraid to take risks, so if people have a dream or an idea or a revolutionary technology or business model, we'd like to hear from you. We have some people in the audience here this evening. I've put their faces on the screen so they can't escape. Hunt them down and speak to them. And we have a website, so if you've got an idea and you don't want to talk about it, just submit it to the website. Our general philosophy is not to take your idea from you, but to give you the resources you need to go away and make it happen.
I see all the Game Changers are centrally located near the front of the stage, so if you have an idea, right up here in the center, front and center, you can come and talk to them. And Chris is going to tell you about our Corporate Connections program.
Yes, thanks. So as Graham mentioned earlier in the introduction, Ultralight Startups helps companies connect with startups. We've created a Corporate Connections program to make it really easy for you to get involved. So if you'd like to get involved with the Corporate Connections program, we'd invite all of you to check in with Mike Simmons or Sarah Groen. If Mike and Sarah, do you want to raise your hands? They're just off to the side here. They can scan your badge, and that will just capture your information. And so we'll have that recorded. So if you'd just like to get involved and learn more about the Corporate Connections program, please check in with them. So we're going to take a break, but do not leave the room. We have 4 more pitches to go through, and then we're going to move right into the voting session. So as said, if you'd like to stretch your legs, scan your badge, feel free to move over there, introduce yourself to someone near you, and then come right back, and we'll have 4 more pitches, and you'll vote for the winner of tonight. Thank you.
Okay, so if you can find your seats, we're going to get started with the final 4 pitches and the contest. So who is up next?
That's great.
It is
Thanks for saying hi.
Chase McCarthy and Altanera.
Now we're getting into good.
Find your seat. You got your microphone? Come on up.
Just say something about the echo.
We have heard several complaints about an echo on stage. I don't know if there's anything we can do about that, but we will work around it. So Chase, whenever you're ready, you got 3 minutes.
Great. So Altanera is a wind harvesting technology company. It's working on our first product, which is the Brisbee wind panel. The panel has a set of reeds which vibrate back and forth in the wind, and this is what produces energy.
Speak a little louder and into the microphone.
Okay. It makes no noise. It has no rotating parts. It works in any wind condition, including turbulent winds, which you will find in urban environments. It's lightweight. It's very portable. It's made from common materials and parts, and therefore we expect it to be inexpensive and easy to manufacture. We have the next slide, please. Now, from a business perspective, when the conditions are right, we see wind and solar as being very strong and natural complements, and obvious kind of analogies of sunny during the summer and windy during the winter. Because the Brisbee panel will be working at a price point similar to or better than solar PV, we see solar companies beginning to use the Brisbee panel for hybrid installations for a number of reasons. The skill set needed for the installation of solar panels is easily transferable to the installation of a Brisbee wind panel. The infrastructure that both technologies use is common and therefore a shared cost. And in general, it's a way for the solar companies to diversify their revenues and improve the ROI on these investments with kind of a broader, expansive energy production through marginal cost. From a standalone perspective of a Brisbee panel, we're looking at municipalities with existing tall structures like water towers and bridges as a great opportunity for these cities and towns to repurpose these structures as sites for clean energy production. Sorry. For clean energy production. And basically in novel and rather efficient ways because of the design of the Brisbee panel. Okay? From a price point perspective, everything that we're doing in terms of the design, the material, and the manufacture of the panel is geared to give distribution channels very normal margins while still giving the end consumer a product that provides 20 to 10 cent per kilowatt hour rates, and that's before any government incentive program. We're looking for $3.9 million over the next 18 to 22 months to finalize prototype, product development, and go to commercialization.
And time. Perfect. Any order, we're going to move the questions to keep them short, and the answer is sweet. So if we can move a little bit quicker. David, please jump in.
Sure. So 10 to 20 cents is a large range,
yeah,
relatively, in cost. So what's going to determine whether you're 10 cents or 20 cents?
So we are in prototype stasis right now, and the efficiencies are improving on a regular basis. For me to give a really hard number, we don't feel comfortable with that, but I'm giving you a range which we do feel comfortable with. And it depends somewhat in terms of the scale of the application, whether it's residential, commercial.
One other quick question is, can this handle, do you have any idea whether it can handle very high wind speeds?
I didn't hear you, I'm sorry.
Yeah. Do you know if this can handle very high wind speeds? As you know, when it's standing up, it looks like you might have an issue with extremely strong force of winds.
Yeah, it's not so much of a sail as just simply a set of reeds which actually kind of handle low winds but also high winds, and they can be tuned for the amount of, for different types of wind sectors.
David Wells, you have a question.
Is the basic mechanism piezoelectric?
No, it's not. We don't use crystals, no.
Is there a novel basic mechanism of converting kinetic motion
So it's
to...
using Faraday fields, and it's a patent that we have.
Okay. And what is your watts per area?
Okay. The best answer that I'm going to give you is that when you take a look at a like-to-like of an investment in solar panels versus wind panels, you would be able to develop an installation that would give you 20 to 10 cents per kilowatt hour, and that's my best answer.
And what's your watts per kilo?
Watts per kilo?
Sure, your materials are like bread and butter. They cost by the pound. So anything in wind, you have to know the watts per kilo that you can generate, and you need a power curve. And to compete with solar, you need watts per area because you're looking at installation area. But I would say also, well, I'll save that for the feedback portion. Thank you.
More question? Yes, Yaniv.
So I think you said you're planning to both go with solar and do standalone, right? One of the major things with any of this is financing, not your company's financing, but financing of the projects. Have you thought about that? Because wind doesn't enjoy the same kind of programs, and supplemental help that solar does right now, right? So how do you think about the financing arm of this?
So again, it's going to depend on the conditions of the site, and so when those conditions are right and a hybrid installation makes sense, that's when the kind of cogeneration of the wind and the solar solution would make sense at a residential or commercial scale. And in terms of programs and incentives, that would depend on the market.
Well, so on the residential side of things, right?
Right.
Average Joe in his house is not going to pay however many thousand, I'm assuming, dollars to put this on his roof, just outlay. There's a payback period. It's probably not a month, right? And so how do you think about that? So in the solar space, there are interesting models like Sunrun, Solar City, right? Have you thought about that for wind and this particular application?
So again, at the residential and commercial scale, that's where we see working with the solar companies and really using them as a reseller market for conditions where a hybrid solution makes sense. And then at the larger, more municipal scales where bonds can be issued and things like that, working at standalone solutions.
Okay. We're going to move right into feedback, if that's okay, Yaniv. And Richard, could we start with you?
Okay. Well, my feedback would be send me an email explaining the following questions. Some things I don't understand that you maybe need to explain in the presentation. You'd say it's based on wind and it vibrates, yet it makes no noise. I'd be interested to hear how that happens. I'd be interested to see about the power output, and you talk about your first customers being sort of water towers, municipal buildings like that. I'd also be interested to hear what they think about that in terms of the wind loading. I doubt those water towers are built to take that kind of wind loading. But that's something you might want to look into. And the last one is I'm concerned that you say they're tunable, but the way the system, and I don't really claim to understand it completely, but it sounds like it's highly tuned. And that if you've got it set for a certain frequency or a certain wind speed, if you go outside that range, you're going to get quite a significant drop-off. But I wasn't able to ask questions, so I don't know.
Yaniv, you look like you have some feedback.
Yes, David doesn't get to go first. I blanked again. You David, can go. You, David, can go. You go first. I'll come right back to you.
We can copy him.
I'm going to borrow my pen.
Yes, David.
Okay. All right. So you're comparing yourself to solar. So one thing you have to realize is that the cost of solar installations are coming down significantly over time. So it's a moving target if you're comparing yourself to that. Also, from the policy perspective, solar does enjoy policy advantages. I think it would be to your advantage to find or create policy advantages for your technology, or you're going to be at a significant disadvantage. Also, I think you want to look in, if you're looking at particularly residential type installations, you want to think about the aesthetics. And really think about consumer acceptance from that perspective of are people going to want to have that system on their houses? How are they going to accept it? Is it going to be something favorable or unfavorable? And actually do the research to determine that.
Go for it, Yaniv.
I think the financing point that I made is not insignificant for this. And the reason being, solar panels are proven technology right now. There's very low technology risk at this point, right? Yeah, we're developing and changing, and there's technology risk in those companies. But generally, straightforward commodity in a lot of ways, right? Yours has a lot of technology risk, right? It's a totally new idea, totally new concept in its infancy, right? So you're going to have to think of how you're going to be able to generate financing for something like that, because in any of these installations, you have to have that element of it, or you'll never get off the ground.
So I'm echoing, I guess, a bit here. You have to use the right comps when you're illustrating the advantages of your technology. The comps you're using on solar don't reflect the real prices today. I just put solar on my roof in California. It's going to be 12 cents a kilowatt hour at a 20% capacity factor. I don't know what your capacity factor is. You need to learn the language and metrics of your industry, like the metrics that I mentioned, watts per area and watts per kilo. I didn't get to ask you capacity factor, but you need to learn all that vocabulary and learn how to speak about your technology that way. And I just want to reinforce what Yaniv says. Without financing mechanisms, it's a hobby.
Excellent. Thank you so much, David. Very concrete. And thank you, Chase. Round of applause for Chase McCarthy, Altanera. Next pitch is Mike Brewer of Graviton Energy Resources. So, Mike, 3 minutes, whenever you're ready.
Over the last decade, a huge amount of money has been invested in distributed power systems. However, these systems are not always reliable, consistent, or cost-effective. Graviton Energy Resources is developing a continuous cycle, scalable distributed power system that is reliable and cost-effective. The Graviton system captures the daily thermal energy created when the temperature in our atmosphere changes. This temperature differential causes a change in pressure in our system, which we use to raise a mass in a cylinder. Once lifted to its maximum height, the mass is locked in place and the potential energy is stored until power is needed. When the mass is released, the resulting mechanical energy is used to power generators, pumps, or other devices as desired. In short, we have discovered how to produce continuous cycle electricity or power other devices from the thermal energy created when the air temperature changes. The Graviton system is different from other alternatives because in one device, it addresses the issues of energy capture, energy storage, and energy transmission. First, we can capture the energy from our sun in the form of heat, which exists everywhere in the world. This source of energy is virtually unlimited. Second, we can store mechanical energy for an indefinite period of time to be used only when desired. No batteries or other resource-reliant devices are needed. Third, as temperatures change practically every day, everywhere on planet Earth, the Graviton system is designed to capture that localized energy and produce power locally at the site where it is needed. Therefore, long-distance transmission requirements are minimized. Slide. Graviton is in the business of selling power. Our cost of operation will be low because our system uses simple mechanical components and we use no external fuels. Amortizing the Graviton system over a 20-year plus life provides for a very low levelized cost of energy, and the system is highly scalable to address different power needs. We believe that our system will best fit customers with large power requirements. However, we are still in the R&D phase, and we need to complete our development efforts before we can determine the best go-to-market strategy. We have completed a first stage prototype, which proves technical feasibility. We have a second stage prototype currently under development, which will prove continuous cycle operation, and a third stage prototype on the drawing board, which is a 100 kilowatt power plant that will prove scalability, cost effectiveness, and commercial viability. We believe that we can accomplish these R&D phases in approximately 18 months. We are looking to raise capital to complete our R&D phases and bring the Graviton system to market. Thank you very much for your time.
Great job. Yes, Yaniv, question.
Yeah. You just came in and told me you could save the world's energy problems in a reliable, cost-effective, scalable way, and I have no idea how you do it. So all the buzzwords were there, but I need to know what you're doing. Like, what is this device? What is it? I have no idea.
Okay, so as I mentioned, temperatures change everywhere, every day on planet Earth. We can take those temperature changes, that thermal energy, and we put our system within that environment, and we convert that thermal energy in a pressurized system to convert that energy to mechanical energy, which can be in the form of a raised piston, a compressed spring, or other mechanism that can store that energy mechanically for an indefinite period of time. It does not go away. And then when you need to release that energy, you release it. The mechanical energy is then run through a device that converts that into running generator, pumps, or other mechanical devices.
And what have you figured? So that's a thermal energy mechanism, right?
Mm-hmm.
Standard. What have you figured out secret sauce-wise that makes yours different from everybody else's?
What makes ours different from everyone else's is that we not only capture, that we conserve, basically we're taking energy that already exists in the atmosphere. Okay, that exists everywhere. Conservation of energy, basically we move that into a mechanical system, and then we store that mechanically. So no batteries or other resource-reliant devices. And then as that's stored mechanically, when we need to release it, we run that through a drive shaft, a common drive shaft, and we run a generator. So we solve the problems of energy capture, taking that out of our environment. We store it, no batteries, no chemicals, and then we can release it when we need it. And because the temperatures change everywhere, we produce that power where it's needed. We don't need to transmit it.
Okay, we only have time for 2 more questions. We need to keep the answers more concise. So 2 more questions. Would anyone else like to jump in?
I got 3 questions. So.
And no favorite. Pick your favorite.
Have you determined what your levelized cost of energy
Our predicted
is?
levelized cost of energy right now looks to be less than 2 cents a kilowatt.
Okay.
Go for it, Richard.
Cost was one. Size and how much energy do you store?
I'm sorry, I couldn't.
How big is this thing and how much energy does it store?
Okay, so that's a very good question. Most energy and energy densities are 2-dimensional. This is 3-dimensional. So temperatures change here, here, and here. Our 100 kilowatt power plant that we're having the design phase is going to sit on a 20 by 30 footprint. 20 feet by 30 feet. That's a 100 kilowatt power plant on a 20 by 30 footprint. Yeah, you heard it correct.
Okay. So David Wells, if it's okay, we'll start with you for the feedback session. Takeaway advice, send Mike on his way. Send Mike with the best information to take his company to the next level.
Very interesting presentation. There's not a single number in it. So my advice to you in pitching investors and in making the case to potential customers and partners is you have to quantify what you're doing. And you also need to make a case that your approach to this use of physics is somehow advantaged to what anyone else can do to this approach to physics.
We're also comfortable with the fact that there's always a trade-off, right? We all know this. Every scientist can tell you that, right? And you've told me there's absolutely no trade-offs, which I've never seen. So I'd love that to be more, it's okay with investors to tell us what the risks are, and if we're ready to accept them, we do. And we do that all the time, right? But there's definitely no risk in this project. And I'd love to hear, and the numbers is a very good point also.
Have you considered other sources of power would be something? I know this is all thermal and you've done it by the sun, but there's lots of other things like low-grade waste heat coming out of power plants that's thermal, and this would concentrate that. And I'm still not quite sure whether your secret source is the capturing or the storing, but if it's one of those, then maybe you've got something.
So this certainly falls into if they can do what they say they can do, right, from our perspective. So, similar to what I've said before, if you can actually produce one of these systems, put it at a customer site and have it operate for a year, and have hard data on that operation verified by a customer, then us investor types will be a lot more comfortable believing that this can really do what it says. So I think that getting to that stage, and I see you're along that path, but getting to that stage where you have some hard operational data will be extremely beneficial.
Okay. Thank you, David, and thank you, Mike. Round of applause for Mike and Graviton Energy Resources. Next up, we have Russ Wilcox and Transatomic Power with his uranium molten salt reactor.
Hi. Nuclear power today faces 3 big problems. It's working?
You're okay.
It's good. It unnerves the public, it creates long life waste, and it costs too much. Transatomic power addresses all three problems. My name is Russ Wilcox. I was the founder of E-Ink, the company that developed the electronic paper display in the Kindle. And after 13 years of entrepreneurship, we sold that company for $500 million in 2009. My co-founders are Mark Massey and Leslie Dewan, PhD students at the MIT Nuclear Engineering Department. They were inspired by Fukushima to find a better way. And the key that they saw was liquid fuel. Today's reactors use solid fuel, uranium oxide, which traps heat, leading to core meltdown or steam explosion. Liquid fuel conducts heat easily and substantially eliminates those risks. Solid fuel breaks down and requires frequent replacement. With liquid fuel, we can achieve a clean and complete burn. We can reduce the amount of long life waste from tons to a few kilograms. With liquid fuel, we can also burn the spent nuclear fuel that would otherwise be stored under Yucca Mountain from other reactors. But nuclear needs an economic transformation as well. And so Mark and Leslie figured out how to cut the size of a liquid fuel reactor from past sizes, not by a factor of 2 or 3, by a factor of 20. Next slide, please. With compact size, we can build these in an American factory with high quality and low cost and ship them globally. A utility no longer has to spend $6 billion on a mega project for a plant that's too large. Now they can spend less for an incremental addition. And once built, the fuel is abundant, zero carbon, and virtually free. So now you understand why there are 3 big problems with nuclear: safety, waste, and cost, and why Transatomic solves all 3. Our pathway is further simulation and test, leading to prototype, leading to commercial units. We are joined by experienced consultants and our advisors, Richard Lester, the chair of the MIT Nuclear Department, and Jess Jean at Oak Ridge National Lab. And tonight, in front of this crowd, we are proud to announce that Mike Corradini, the president of the American Nuclear Society, and Todd Allen, deputy director at Idaho National Lab, and Regis Matsey, the former chief technology officer of Westinghouse, have just joined our advisory board. So remember, there are 3 problems with nuclear, and Transatomic solves all 3. We are the right company with the right technology and team to bring this to commercial reality, and you can start the transformation tonight. Please give us your vote.
Thank you, Russ. Moving right in for questions and answers. So, any order, who would like to jump in and start the question session? Sure, David. David Wall.
This has been on again, off again for 50 years. I'm not sure I understood what your innovation was that made it be on again.
Good question. Molten salt reactors were tested 60 years ago, but at the time they used graphite as a moderator. About 90% of the volume of the reactor was filled with graphite, which has aging problems, and it really was not any economic advantage. Mark and Leslie figured out how to get rid of the graphite. They have shrunk it by a factor of 20. It enables modular production and changes the game entirely.
Next question. Yes, David.
So, have you thought more about first market?
So, first market is it's a good question. We've talked to people in the utility industry. The 500 megawatt size that we're proposing to launch with is something they're very excited about. No small modular reactor that's in view today can do that. We also are getting a lot in our ears about Alberta tar sands and process heat applications. And then, of course, I've had calls from utilities who are interested in a revenue stream from waste elimination.
Richard.
Yeah, so you're taking waste from nuclear power plants?
We can use either fresh uranium or the spent fuel rods from nuclear power plants. It's easier to use fresh uranium. In either case, we're able to burn 97% of the fuel potential, as opposed to current reactors only burn 2 or 3%.
Okay. And you said you can ship this globally. Are you not covered by government? Are there any governmental export controls?
There are serious governmental export controls, and we've already incurred legal fees getting trained on export control issues. However, if the export conditions permit, and certainly DOE has been enthusiastic about the concept of about an American factory exporting modular reactors, then we think that we should be able to ship these everywhere that currently you can ship a light water reactor.
Final question, Yaniv.
Yeah, your, let's call it the product, right, that you're going to sell is pretty big, right? So how much money does it take to build that basic product to prove that it actually works?
Well, you're asking two different questions there. You're asking about product
Sure.
and proof.
I'll take the answer to both. Go ahead.
Okay. So let's start with the product. And it's sort of behind you, but the current product is a $6 billion price point for 1 gigawatt. That's what people pay right now for nuclear power plants. Ours is 1.7 for half a gigawatt. Okay, so it's a more modular product.
Yep.
Okay, and then, however, the technology is very scalable. So there's a voice of the customer piece here where we find out if it's 50 megawatts or if it's 500 megawatts, and we could do either, and it doesn't really change the first 2-3 years. Then the second question is, what does it take to prove? And I think our first step here is to basically do the benchtop tests to very quickly test the models and make sure they're calibrated correctly. And that's like $1 million times 5 experiments. It's about $5 million. So I want to raise about 10. I'm looking for 3 people who can each write a $30 million check, but they'll only write a $3 million check right now. So that's 9. I've already raised $1 million of seed money. And so that $10 million should get us to technical feasibility on our top 5 risks. Maybe we have to do another round of another 10. But that $20 million is a huge bargain compared to being able to show that you've de-risked this approach.
Jenny, would you like to start with the feedback, or would you like to think about that?
Sure. $1.7 billion is a lot of money. And so I'm concerned with the financing aspect of things. I mean, I'm not really clear of how you prove this out and are able to scale it with these big, very powerful customers who already have a way of doing things that makes them money. And by the way, a lot of them have not been able to expand, and it takes them like a decade to build a new power plant, right? So I'm not really clear how it works from a less than $1 billion infusion of capital perspective.
Other feedback?
Sorry.
Yes,
oh, sorry, go on. Yeah, just busy coughing. Yeah. I mean, I think Jonas hit it on the head. It's how you get from where you are now to that. That's a huge leap, and I can't see where those stepping stones are to step on. Although I do like the idea of burning waste fuel. That seems kind of cool and almost too good to be true. But yeah, good luck.
David Wells, go for it.
Version of the same, that the amount of money and the time scale involved is basically out of the range of the venture capital business model unless you can identify a path to a business that involves less time and less money.
Sure.
Well, you have an extremely impressive team and board of advisors. I really can believe that this will solve very big problems. But, the question is, how do you get this to market? And this is why I was asking about first markets. So, to the extent that you can reduce the capital requirement to get this to an initial market, I think just thinking that through as much as possible. Because, the end game, it works. I mean, where you are today, you have a great team. At the end game, you have a great technology that can solve significant problems in the world. But finding that pathway, and the pathway might not be, you're looking at a direct path. The path might be a little bit more winding.
And congratulations on your announcement.
Thanks, guys.
Yeah.
Fantastic. Thank you, Russ. Round of applause for Russ Wilcox and Transatomic Power. So our final startup presentation today is Craig McKenzie and Pacific Air Conditioning.
Hello. Thank you for being here tonight. What we have is a solar compressor connected to a co-generating heat exchanger. What we are trying to do is take this unique approach, take your commercial, residential air conditioning units, that compressor, run it off the grid, take it off the grid. That's what we basically are doing. We can multi-generation with the collector that we're using. that we can not only take care of your air conditioning, we can take care of your domestic hot water, water reheat, or power generations, or go off the grid altogether. And we are taking a piece of equipment that always uses a large grid amount of power and turning it into renewable energy. That's basically what we're running. We're capturing heat and temperature with our collector. Thank you very much.
Record time. Okay, questions for Craig?
How does it work? How does it work?
Oh, we're capturing, if you look on the screen there, we're capturing the sun with the collector, doing with the Freon R410A. It's already in existence, and we are driving your compressor a different way versus using electricity on the grid.
So does it require electrical backup for when the sun's down? Does it require an electrical backup power supply for when the sun goes down?
Oh yeah, you're still going to be able to be hooked into the grid. It's just going to be another way to function that compressor.
Go for it, Yaniv.
No, I was thinking.
You look
Can you give us some numbers that you've modeled? What's the price per watt capacity? What's the price per kilowatt hour for the energy it will make?
That we do not have. We are just in the technology demonstration phase of it. We are projecting costs below $20,000 for this system. We're trying to actually drive your meter backwards every day. So whatever you're spending in your electric bill right now, we're going to try to match that and drive it backwards.
What's the payback period on that?
It all depends on where you're living. If you're living in the Southwest, you're going to get a lot more sun versus living in Chicago. So it all depending on where you're living.
Give me like a year's range. 3 to 5 years, 5 to 10 years, 1 year.
We're looking at probably about 2 to 3, I'd say.
Okay.
So can you describe the initial market for this? Where's the first market you're going?
Well, on the second slide, you'll see we just had a couple of numbers come out through the Wall Street Journal. 13 states, they're estimating $32 billion in revenue. That's what that's what my customer wants. We have an expected 20 million from 11 million in 2013. So my projected customer base is actually maybe 8 million projected units if we take the whole pie.
Feedback. Okay. David Miller, start here. Go for it.
Okay, so this will be a combination of some feedback we've heard before. So question number one is you got to figure out all the numbers behind the system. What is the actual cost savings compared to conventional systems? What's the cost per kilowatt hour and payback period and so forth? And you really have to focus on figuring out who is your initial market. You have a lot of different potentials listed. Who exactly? Who is that actual? Who are you going to talk to first? Who are you when you pick up the phone? What number are you going to dial? Who is that customer going to be? Is it a residential user? Is it commercial? Is it military? And how are you going to meet their needs? What are they looking for? And how are you going to solve their problem? How much is it going to cost them? Why do they want to buy your system versus any other system? And how can you prove to them that your system will meet their needs?
There's no response to this. This is just takeaway advice, and it's great advice. Other feedback. Yes, Richard.
Yeah, echo that, but also just in terms of the numbers I'd like to see, what's the advantage over competitive technologies like PV? Why wouldn't I just, as a customer, just buy PV and put that on and use that to power my HVAC? I still don't understand how big this is, how many of these I would need to put on my roof, and what the price is. So numbers like that would be good.
Residential, again, suffers from the same financing issue that our past presenter suffered from. And one thing I think about is what's the go-to-market? With the business model? There's a lot of different ways you could do it, right? Are you going direct to consumer? And in that case, why did you pick that? Versus going to channel partners, of which there's a lot in this space, right? versus, maybe partnering with a big existing person in the industry. So I would think about that and kind of hash it out for us, because I think that has implications for how successful or not your business might be.
So David Wells, what's your last piece of feedback for the last pitch of the night?
Everything they said, plus it seems like there's a learning curve in these markets and this business, and it seems like you're still at the beginning of that learning curve. And I think you need to go out and talk to participants in the market and really learn how they look at it in terms of costs and financing and durability and function, and understand all the metrics and all the language, and be prepared to speak about your work in that language.
Excellent. Thank you very much, David. And thank you, Craig. Well done. Round of applause. Okay, now it's your turn. Vote. Type in this URL. You can get it right off the screen in front of you, or you can get it from your program. Or if you are so inclined, you can scan the QR code that's in your program underneath the voting heading. And you will get to a form that asks you to name your favorite 3 startups tonight and your favorite 2 panelists. Very quick and very easy form. So type that in, and if you forgot the names of our panelists, here they are. David Miller from Clean Energy Venture Group, Richard Smith from Shell's Game Changer, Yaniv Suissa from NEA, and David Wells from Kleiner Perkins, Caulfield and Byers. So get those votes in, and Chris is going to tell you about some of our upcoming future energy events.
Yes. Thanks, Graham. So while you're all voting, we'll give you another minute. Just a few announcements about some upcoming events that we have. We're doing 3 more events for Future Energy just coming up soon, one in Boston, one in Silicon Valley, and one in New York. So the Boston event is coming up on April 4th, and right now we're accepting applications until this Friday. So if you are working for any of these events, if you're working on an energy startup, or if you'd like to apply in any of these cities, you're welcome to apply now. The Stanford, we're partnering with a lot of universities, and as you can see, the Boston event is co-hosted with the MIT Energy Club. The Silicon Valley event on April 24th is at Stanford in partnership with the Stanford Energy Club. Application deadline is on March 22nd, so get those applications in if you'd like to apply. And then back in New York on June 13th, and the application deadline for then is May 10th. So hopefully if you'd like to participate, if you're in any of those cities during those times, we invite you all to attend. I just should mention that normally the Future Energy events are typically standalone events as opposed to tonight's event, which is embedded in ARPA-E. So typically we're doing events that are kind of standalone, and that's really all we have.
2 hours long. It's a contained evening event as opposed to part of a larger 3-day conference. So our events at MIT, at Stanford, and New York are all going to be basically 2-hour evening events. The exact same format, the exact same length, 8 pitches, 4 panelists, feedback, just like tonight. So show of hands to see if you're still voting. Anybody still voting?
Is anyone still voting?
A couple of people are still voting. Okay. So Chris, tell us a story.
Do the dance. No jokes. I don't have any jokes. Getting your votes.
Future Energy has been around for just over a year now. We've had 4 events, 2 in New York, 2 in Boston. The Silicon Valley is a new expansion for us in 2013, and we're very happy to partner with Stanford University and the Stanford Energy Club. So if you are an early stage startup, or if you know somebody who is, this is a fantastic platform to get the word out about your technology and to get some feedback from investors. You can hear what they all think and how they all receive your pitch.
Also, we've seen this kind of serve as a platform. A lot of companies are, as you're seeing, debuting. So the very early stage, they're kind of debuting their product or technology tonight. And a lot of them actually go on to accelerator programs, incubators, and kind of that's the progression path we're seeing. So we encourage you all, if you know anyone or are working on one, feel free to apply.
Okay, so we are going to wrap up voting right now. So if we can bring up that SurveyMonkey page whenever we're ready, and it will show us a lovely bar chart here of who got the most votes. Transatomic Power, is that correct?
Oh, wow. Looks like
that looks like number 1.
Yeah.
Number 2, I would say, is BDL Water. And number 3, who's number 3? 45? That would be Hivo. Is that correct?
Hivo. Yeah. That is correct.
Okay, so come back up on stage, guys. The winners, top 3 companies.
Congratulations.
Whoa. Okay. Top 3 companies come back on stage. Go shake their hand. Well done, guys. And now for the really, really big prize. Who was your favorite panelist tonight? Look at this. David Wells from Kleiner Perkins Caulfield & Byers took it away tonight. Congratulations, David. His first time on the panel.
David.
And he blew it out. All right. Well done. So let us show the thank you slide. We're going to thank ARPA-E for having us here tonight. We are going to thank all of our panelists, David Wells, Richard Smith, Yaniv Suissa, David Miller, and we are going to thank Technology Forums for hosting us. We're going to thank all of our partners for the contest. And we look forward to seeing you outside at networking. And don't forget, if you would like to contact us to hear about our Corporate Connections program, if you're a corporation and you want to get in touch with startups, or if you are a startup and want to get in touch with corporations, we help make that connection. So thanks very much, and we'll see you out in the foyer.
Thanks all. Have a great night.